Hello friends, let us take in another topic in vector calculus, which is arc length along a space curve. So here we shall calculate the arc length of a curve in space. Now that is similar to calculating the arc length for a curve in the plane. See, as a layman we can do like this. To visualize the arc length of a curve is to think of the curve being a piece of string and then taking that string and extending it out until it becomes a line, which we can then take and measure along a ruler to find the curve's arc length. Since we can't actually take the curve and measure it that way, we must use another method, and here mathematics helps us. So the length of a parameterized curve in a space, say RT, is say xi plus ytj plus ztk. Say t ranges from A to B, and we would like to write the formula for length of the arc. So the formula is like this: length is integration from A to B under root dx by dt square plus dy by dt square plus dz by dt square, and that integrate for t. So that is the formula to find out the arc length of a curve from A to B. Now we know that this dx by dt, dy by dt, dz by dt, and so the velocity. So we can also write this as integration A to B. It's a velocity vector, so it is root of the magnitude of velocity vector. So that way also we can write. So we can take one example here. So let us have an example. Say in your class, in math class, someone not doing, but let us take one example. Say a student tosses a paper airplane. The paper airplane, its flight, say lasts for 2.5 seconds. And can be approximated by say RT equal to say 1.2 sin ti plus 1.2 cos tj plus 0.4 tk. The question is, what is the total distance that the airplane travels, and consider the units in feet. So we are having everything like here x as 1.2 sin t, y as 1.2 cos t, z as 0.4 t. So we can have dx by dt, dy by dt, dz by dt. So we can have like xt is 1.2 sin t, y 1.2 cosine t, and z is 0.4 t. So we can have dx by dt 1.2 cosine t, dy by dt minus 1.2 sin t, dz by dt 0.4, and say root of dx by dt square plus dy by dt square plus dz by dt square is, it's easy to see. So it's a 1.2 square cosine square t plus 1.2 square sine square t plus 0.4 square, and that turns out to be say root of 1.6. You can verify this. And so the required length, now the flight is for 2.5 seconds, so required length is 0 to 2.5, and this root 1.6 dt, and it's easy integration. So you can have the answer as 3.162, and the unit is feet. Let us take one more example. Find the arc length of the curve say RT is like this: 2t, then 3 sin 2t, 3 cos 2t on the interval 0 to 2 pi, and it's easy now. So here x as 2t, y as 3 sin 2t, and z as 3 cosine 2t. So dx by dt is 2, dy by dt is 6 cosine 2t, dz by dt is minus 6 sin 2t, and if we can find root of dx by dt square plus dy by dt square plus dz by dt square. So that is nothing but this is 4 plus this is 36. So that is root 40. You can have 2 root 10, and the required length is integration from 0 to 2 pi 2 root 10 dt, and so answer is 4 pi root 10. So that's easy. I can give some example to you as homework also. So let us solve yourself some examples here. So write, find the arc length of the core say RT equal to 4 plus 3 Ti plus 2 minus 2 Tj plus 5 plus Tk, and T is from 3 to 4. So it's not difficult, you can find the answer. You will get the answer as root 14. Let us have one example. Find the arc length of the core say R equal to 1 plus 3t square I plus 4 plus 4t cube j between t equal to 0 to t equal to 1. Now here you are given a plane curve x and y. So here x is 1 plus 3t square, y is 4 plus 4t cube, and so dx by dt is 6t, dy by dt is 12t square, and this root of dx by dt square plus dy by dt square equal to 36t square plus 144 t to the power 4. Okay, we can have like this also, say 36 to 6, and t we can take it outside. Remaining here is 1 plus 4t square. So required length of arc is integration from 0 to 1, t equal to 0 to 1, this is 6t root of 1 plus 4t square dt. Now we need to take the integration, so that's not difficult. You can integrate like using the formula fx power n into f dash x is fx power n plus 1 upon n plus 1, because here the derivative of 1 plus 4t square you can have 8t, so that we can manage. So you can write like this, say 3 by 4 t equal to 0 to 1, 1 plus 4t square power 1 by 2, and the derivative of 1 plus 4t square is 8t, and we have divided by 4, so it's okay. And so the integration is 3 by 4 1 plus 4t square power 3 by 2 over 3 by 2 from t equal to 0 to 1, and simplify yourself, you will get the answer as 1 by 2, this is 5 root 5 minus 1. Okay, I give one more example to you as homework. Find the length of arc of the core r equal to cosine t I plus sine t j plus t k, and that is 0 to 2 pi. Not difficult example, you will get the answer as 2 root 2 pi. One more example you can have. Find the arc length of, this is called catenary curve. Catenary curve, say RT as t cosine hyperbolic t and 0 from t equal to 0 to t equal to 1. Here you have to use one formula of hyperbolic function, and that is nothing but cosine hyperbolic square t minus sine hyperbolic square t equal to 1. I think that formula you need to use.